The Mars 2020 Perseverance Rover will search for signs of ancient microbial life, which will advance NASA's quest to explore the past habitability of Mars. The rover has a drill to collect core samples of Martian rock and soil, then store them in sealed tubes for pickup by a future mission that would ferry them back to Earth for detailed analysis. Perseverance will also test technologies to help pave the way for future human exploration of Mars. The Perseverance rover has 4 science objectives that support the Mars exploration program's science goals. Looking for habitability, identify past environments capable of supporting microbial life. Seeking biosignatures, seek signs of possible past microbial life in those habitable environments, particularly in special rocks known to preserve signs of life over time. Caching samples, collect core rock and soil samples and store them on the Martian surface. Preparing for humans, test oxygen production from the Martian atmosphere. Perseverance is set to explore Jezero crater. From orbit, this crater shows all the promising signs of a place that was likely friendly to life in the distant past. The rover's goal is to study the site in detail for its past conditions and seek the very signs of past life. Its mission is to identify and collect the most compelling rock core and soil samples, which a future mission could retrieve and bring back to Earth for more detailed study. Perseverance will also test technologies needed for the future human and robotic exploration of Mars. Perseverance rover will carry 7 primary instruments. Must-CamZ, an advanced camera system with panoramic and stereoscopic imaging capability and the ability to zoom. The instrument can also help scientists assess the mineralogy of the Martian surface and assist with rover operations. Mars Environmental Dynamics Analyzer, MEDA. A set of sensors to provide measurements of temperature, wind speed and direction, pressure, relative humidity and dust size and shape. Mars Oxygen Issue Experiment, MOXIE. An exploration technology investigation to produce oxygen from Martian atmospheric carbon dioxide. Planetary Instrument for X-ray Lithochemistry, PIXL. An X-ray fluorescence spectrometer with high-resolution camera to determine the fine-scale elemental composition of Martian surface materials. PIXL will provide capabilities that permit more detailed detection and analysis of chemical elements than ever before. Radar Imager for Mars Subsurface Experiment, RIMFAX. A ground-penetrating radar to provide centimeter-scale resolution of the geologic structure of the subsurface. Scanning habitable environments with Raman and luminescence for organics and chemicals, SHERLOC. A spectrometer to provide fine-scale imaging and use an ultraviolet, UV, laser to determine fine-scale mineralogy and detect organic compounds. SHERLOC is the first UV Raman spectrometer to fly to the surface of Mars and will provide complementary measurements with other instruments in the payload. SuperCam. An instrument that can provide imaging, chemical composition analysis, and mineralogy. The instrument can detect the presence of organic compounds in rocks and regolith from a distance. NASA chose Jezero crater as the landing site for the Perseverance rover. Scientists believe the area was once flooded with water and was home to an ancient river delta. The process of landing site selection involved a combination of mission team members and scientists from around the world, who carefully examined more than 60 candidate locations on the Red Planet. After the exhaustive 5-year study of potential sites, each with its own unique characteristics and appeal, Jezero rose to the top.